Cosmic Chronicles: How Gravity is an Effect of Mass Displacing Spacetime. Welcome back, cosmic explorers of the UNSS Phoenix XCS-337. Today, we're tackling one of the most fascinating concepts in modern physics: gravity as an effect of mass displacing spacetime. While we often think of gravity as a force that pulls objects toward one another, it's actually a consequence of how mass bends and warps the fabric of spacetime. This episode will take you on a journey through the mind-bending world of general relativity, where space and time aren't static, but flexible, and mass is the artist shaping their curves. Let's dive into the strange, beautiful dance between mass, spacetime, and gravity, and explore how this relationship governs the motion of planets, stars, and even light, the fabric of spacetime. To understand how gravity works, we first need to grasp the concept of spacetime. Spacetime is a four-dimensional fabric that combines the three dimensions of space, length, width, height, with the fourth dimension of time. In this model, everything, planets, stars, and even light, moves through spacetime. But what makes this fabric so interesting is that it can bend, stretch, and curve based on the presence of mass and energy. Imagine spacetime as a large, stretchy rubber sheet. When you place a heavy object, like a bowling ball, representing a planet or a star, on the sheet, it causes a dent or a curve in the fabric. This curvature is what we perceive as gravity. The more massive an object is, the deeper its dent in spacetime, and the stronger its gravitational pull. This curvature affects the motion of other objects around it. For example, if you roll a marble, representing a smaller object, around the bowling ball, the marble will spiral toward the center of the dent, mimicking the orbit of a planet around a star or the way a satellite moves around Earth. Cosmic fact: spacetime bending is the core idea of Einstein's general theory of relativity, which replaced the older Newtonian idea of gravity as a direct force between masses. Mass warps spacetime, the origin of gravity. The warping of spacetime by mass is the foundation of how gravity works. According to Einstein's general relativity, mass and energy tell spacetime how to curve, and the curvature of spacetime tells objects how to move. This is a radical departure from Newton's classical view, where gravity was thought to be an invisible force that acted instantaneously across distances. When an object has mass, it distorts spacetime around it, creating what is known as a gravitational well. Think of this as a depression in the fabric of space. The larger the mass, the deeper and wider the well, and the stronger the gravitational effect. This warping explains why objects, including light, follow curved paths when they pass near massive objects. For example, the Sun's mass warps the spacetime around it, which causes the planets to orbit along curved paths. The Earth's orbit around the Sun isn't just a straight line, it's a result of the Earth moving along the curves in spacetime caused by the Sun's mass. Riddle: I am bent by the weight of the stars, shaping the path of planets near and far. What am I? The role of gravity in shaping the universe. Gravity, as a result of mass displacing spacetime, plays a key role in shaping the universe. From the formation of galaxies to the motion of stars and planets, the bending of spacetime governs how matter behaves on cosmic scales. Orbits of planets and stars, planets orbit stars, and stars orbit the centers of galaxies, all because of the way mass curves spacetime. The deeper the gravity well, the tighter the orbit. This is why the planets close to the Sun, like Mercury, move much faster than distant planets like Neptune. Gravitational lensing: one of the most fascinating consequences of spacetime curvature is gravitational lensing. When light passes near a massive object like a galaxy or a black hole, the spacetime around the object is curved so much that it bends the path of the light. This can create multiple images of distant objects or magnify them, allowing astronomers to see galaxies billions of light years away. Black holes. Black holes represent the extreme end of mass displacing spacetime. They are so dense and massive that they create infinitely deep wells in spacetime. Once something crosses the event horizon of a black hole, not even light can escape, making it appear black. The curvature of spacetime becomes so steep that all paths lead inward toward the singularity at the center. Cosmic fact: gravitational lensing has allowed us to detect objects that are too far or too faint to be seen by normal telescopes. It's like using the universe itself as a giant magnifying glass. Experiencing spacetime curvature: the effects of gravity on time. Interestingly, gravity doesn't just bend space, it bends time as well. In regions of strong gravitational fields, like near a planet or a star, time actually runs more slowly compared to areas with weaker gravity. This phenomenon is known as gravitational time dilation. For instance, if you were near a black hole, time for you would pass more slowly than it would for someone far away from the black hole. In fact, this effect has been observed on Earth. The higher you are above the Earth's surface, and thus farther from its gravitational well, the faster time moves for you. This is why clocks on satellites in orbit around Earth tick slightly faster than clocks on the ground, a difference that has to be corrected for GPS systems to work properly. Joke: why don't astronauts need to worry about being late? Because time runs slower in space, especially near a black hole. Did you know, Albert Einstein's general theory of relativity was confirmed in 1919 during a solar eclipse, when scientists observed the sun's gravity bending the light of distant stars, one of the first direct pieces of evidence for the warping of space-time. Question for you: if you could visit a place where gravity was extremely strong, like near a black hole or a neutron star, what would you be most curious to experience, seeing how light bends or watching time itself slow down? Share your thoughts in the comments. Coming up next, in our next Cosmic Chronicles episode, we'll explore what events could unite the world as one. What would it take for humanity to come together as a single global civilization? Stay tuned for more cosmic wonders. As we conclude our exploration of how gravity is an effect of mass displacing space-time, we hope you've gained a new perspective on how the universe works. Gravity isn't just a mysterious force pulling objects together, it's the result of mass bending the very fabric of space-time, creating the pathways that everything in the universe follows. From the way planets orbit stars to the incredible phenomenon of gravitational lensing, gravity shapes everything we see and experience in the cosmos. And who knows, perhaps in the future, we'll learn even more about how this fundamental effect drives the motion of galaxies and the behavior of black holes. Riddle: I am the bend in space and time, shaping the paths of matter's climb. What am I? And don't forget to subscribe to Crazy Frank's Crazy Video Productions on YouTube for more cosmic explorations. Stay tuned for new content and fascinating insights into the wonders of the universe. By subscribing, you'll never miss an update. Answers to riddles: space-time, gravity, cosmic comic, space diner delights, the Gravity Well Pizza. An astronaut sits at a space diner and orders the asterisk, Gravity Well Pizza. The alien waiter brings out a pizza shaped like a spiral, with all the toppings sliding toward the center. The astronaut looks at it puzzled: why are all the toppings pulled to the middle? The waiter grins: that's what happens when you've got too much mass displacing your dough. Cosmic recipe: Gravity Well Pizza. Ingredients: pizza dough, representing space-time. Your favorite toppings, representing planets and stars. A heavy sauce and cheese in the center, representing a massive object like a black hole. Instructions: roll out the pizza dough in a spiral shape, thickening the center. Add sauce, cheese, and toppings, focusing the bulk in the middle. Bake until the toppings naturally slide toward the center, creating a gravity well effect. Enjoy your pizza while contemplating how mass bends space, and why your toppings keep sliding into the middle. And thanks for watching.